Hey everybody, welcome back to another Unreal Engine 4 Project Hero live stream where we're going to try to make a game in Unreal Engine 4 using C++, the gameplay ability system, blueprints, the whole 9 yards. I'm your boy, Devin Sherry. Thank you for stopping in. Tonight's live stream's gonna be kind of short. I'm kind of burnt out from work. I had to work a lot of hours today. So we're gonna do maybe hour and a half. I think that's reasonable for me. Yeah, I think that's good. So what we're doing is we have this stylized weather system blueprint that we bought from the Unreal Engine 4 marketplace, and we're working to convert it from blueprint to C++. Right now we have no end result because we're still trying to make that conversion. This is just the working blueprint that we got from the marketplace. But we're slowly creating the actor class. We created these different structs, these enums. We imported our own data table. So if we go to our hero directory under weather system, we have our blueprint that has our hero weather system blueprint. We have our data table. We have curves. I think is it under curves or data table? One of these. Oh yeah. The structs in the enum exist in the class. They don't have their own kind of blueprint thing. I'm wondering what this. So MF cloud layer. Why are these empty? I wonder. All right, so that's empty. It's a random glow is something. Is that the case with this? Yes. Okay. So we're not crazy. All right, so we're gonna continue where we left off. So in order to do that, I'm gonna stop debugging from Visual Studio. I'm just gonna open up our editor the other way. I'm gonna try to remember where we left off. So we were in a function called interpolate param. So we just gotta find that in blueprint. We're getting close to finishing the construction script. Like, this is all construction script. All right, so we did initialize setting. We did all of that. Did that. Actually, so we went to material setting, interpolate param. Okay, so and we did that, right? We did this. There's that for loop. Oops. So that's this function. So that's all this material setting. So we finally get to here. We're set sun param. Oh my god, I forgot how gross this was. Okay, so we gotta make a new function called set sun param. That's gonna be the first thing we do. Go into our header. Go to everywhere else we're making functions. Ooh, 50% off marketplace. Nice. Wish I knew that before. Okay, make a new function. Void set sun param, and it's taking in float called time and a second float called next weather alpha. Okay, let's create that. Now, where is this getting called from? Getting called from our initialize setting function, right? So we gotta do it after here. So set sun param, and it's passing in init hour plus init minute. Put this in a minute is divided by 60, so that's going into time, and alpha is going to remain 0. So, I like this song. So we can do what? When we say float init hour plus float init minute divided by 16. And then we gotta pass in an alpha, which is gonna be 0.0f in this case. So I think that's valid. So I think we're good. So that's essentially this condition here. We set that. And then afterwards, we gotta do a couple more things. But after that, it looks like we're done with the constructor script. So we're getting close. This is a complicated blueprint, so let's not beat ourselves up too badly for taking so long. So let's see what we're doing. All right, so sunrise. So this person's not a native speaker of English because that's not how you spell rise. Not a big deal. So it's a curve float, so we're gonna need a curve float. Let's go back into our header file. Where would be the best place to do this? These are curves, so I guess I could just do a curve float. What category is this under? It's under the sun category. So we can copy this view property, change that to sun. So class u curve float. Or is it float curve? Height curve float. Call it sunrise offset. Now, is this a local variable? Yeah, it's a local variable. So alpha and time rate are local variables, so I'm looking at these guys. So we have the one variable we need right now, I believe. So now set sun param. What are we doing? So we're getting time. Okay, so we gotta do float time rate equals time divided by 24f. And this we have to do sunrise offset get float value at this time. So that's this. We literally just did this. And then alpha is next weather alpha, so we can just pick it. I don't know why. Oh, gotta do that. So float alpha equals next weather alpha. Okay. Now we're doing something in a collapsed graph. So let's see the damage. Not too bad, but it's doing a lot of math, so. What do we want to do? Make a new function. Void rotation, and it's going to take a float called time. Oh, fuck. And create implementation. Here we can call rotation, and we're passing in time rate. Alright. So I'm guessing rotation's already taken. So what is this rotating? Maybe we can get a better idea so we can name it. So it's rotating the sun. Okay. So rotate sun. That should be okay. Not sure why that's complaining. Let's compile and just see what up. we can see that we can evaluate the damage when we get the reports back. This one's taking a while, but okay. Okay, so it looks like everything auto-corrected itself, so we're safe. Okay. We're A-okay there. So we have to rotate, so it's... Alright, so I think we have to make a new float curve called sun angle. Copy that under the sun category, so that's all good for us. And then this is sun angle. So the first thing it does is it takes time. Alright, so in general, it takes our directional light. So directional light. Set world rotation. And then it needs a rotator, so I think we're gonna have to do some funky things based on what I'm seeing here. So we need an angle clamp and rotation setting. So let's go ahead and make these properties. Make it a new category. So it's gonna be new property. All that's good. So the first thing is a float. So I get to say float angle clamp. This one's set to 75 by default. Then we gotta make another one from the sun category, rotation setting. So it's the F rotator. F rotator, rotation setting. I think we can we initialize it? No, we gotta initialize it like this, where it's like 0.0 F, negative 60.0 F. Can I not initialize? What can I do? I guess I gotta do something like that. But how do I initialize it? I completely forget how rotators work. UE4, C++. Initialize a rotator. Let's see what they give us. Got a couple answers. So F rotator, new rotator equals that. So it is F rotator. I mean, is there a constructor? Yeah, why does that not work? There is a constructor for like three integers, 3 floats. Curious. I have to be like F rotator. And then do it like this. The 0.0 F, negative 60.f, and 0.0 F again. That seems like it likes it, so I'll be happy with that. So got this, we got sun angle, and we got angle clamp. So we're basically doing a bunch of vector rotation math, it seems. So eventually we need to set the directional light to a world rotation. So let's make F rotator sun rotation equals I want it. How should I do this? I gotta do this so it makes sense in my eyes. So let's make a float angle. I will say sun angle. No, that's already a thing. Float angle. Alright, so it looks like angle's already taken. As a name. Okay, we'll say rotation angle equals sun angle get float value from time. So that's a float. Now we gotta do F math clamp so this is the const. So the min is angle clamp times -1. Well, I mean, can I just say negative angle clamp like that? Maybe, I don't know. And then angle clamp is max. So basically, we essentially did this. But now we gotta use, so this is the Ukismet math library. So I guess, so now we can say F rotator sun rotation equals F is it rotator? So Ukismet math. I say rotator from axis and angle. So the first one's axis, so we take rotation setting. I say get up vector. Can we say F rotator get up? I don't know how to get the up vector in C++. Basically, we're trying to do this. UE4 C++ get up vector rotator. Okay, so it seems like something exists, but that's the blueprint. This might be what we're looking for. So yeah, get forward vector. So get up vector. So yeah, do I need to include the library? Is that maybe what the problem is? Yeah, I guess we do need it. Let's try including it. UE4 C++ Ukismet library. Got that. Make sure we don't have it. Doesn't look like we do. Alright, let's try that again. Ukismet math library. Get up vector. Rotation setting. Where's the blueprint? Okay, so do we have to do with this like Kismet Math Library, Rotator, and pass in rotation angle? And that looks happy. I don't think I did it like that. I think it'll be easier if I do something like that. And then we could put in sun rotation here. So that's all good. No, it's not. Forgot we need to. Now, so we basically did this and this. So I forgot we have to combine our rotators. So let's do that. And from what I can tell, it's also Kismet in my library. So can we say you Kismet Math Library combine rotators? Okay, so that doesn't seem like it. Which is kind of weird. You Kismet Math Library combine. Is it compose? Alright, so I think it is compose. And A is rotation setting. D is sun rotation. Okay. So we got rotation. So let's see. Oh, let's see what we can do next. So we gotta do set world location. So this is doing something kind of weird. Well, it's not doing something weird, but doing more vector math, which is always fun, right? So, so it's doing what? I don't want to do this as one liner. Oh, it's doing it. It's doing something very similar that we just did. Like, can I not just use like directional light? Wonder why. I guess I'll have to. Like, I should just copy it exactly for one. So rotate sun. All right, now I'm gonna do it the way I think it should work, and then maybe come back to this if something broken. All right, now let's do it. So we can literally take the sun rotation. We need to do some seams. So we take sun rotation and we do some vector math. So we could do something pretty easy with set vector parameter value. So you Kismet material library set vector parameter value. now we gotta do something similar to what we were doing before. There's something where we pass in a collection. Yeah. So this is MP Sky. We can copy that. Then we can use MP Sky. Alright, so it needs context of this. And the parameter name, F name. Sun, is it just sun? Sunder? Yes, sun. Sunder. And then the parameter value. So they make a conversion from vector to linear color. You can see that right here. So how do I do that? Okay. So E4, C++. Convert vector. Let's see what we got. Can I do like that force conversion where I do like F linear color, then I pass in the vector? So it's the rotation vector of that. We need the rotation vector for a couple things, so let's actually make that. So it's U, Kismet, Math Library, get, rotation. Okay, so it's there. Like vector X. Okay. So UE4 C++. Get vector. Get rotation X vector. Like, do I have to do like, I don't know, get rotation dot X? So make rotation from it. Okay. No, I don't want to make rotation. I hate the documents that just show me the blueprint. No. Will this show me anything not blueprint related? Fuck. Click allow. Fine. This doesn't seem trustworthy. Let's see what's available to us. Oh. What? I'm brain dead. Get rotation vector. Don't know how to do this. Kismet Math Library. Now, can I find it here? Get rotation. Alright, so it's this. So rotator to vector. Rotator to vector. And I'm taking in sun rotation. So I gotta make this what? So F vector sun position equals this. I think that's all well and fine. And then can I say sun position? Seems like it doesn't mind that. So we basically did this, and then this, then here, right? Oh, my eyes. So we have sun position, which we're using later. So we then. So basically, we have to set now the sun billboard. Set world location. And the location is going to be sun position times sphere size Yeah, sorry for the late stream. I got caught up at work. I'm only gonna stream for like 25 more minutes or something. It's gonna be a short one. Thanks for popping in and reminding me to hydrate. I always appreciate you. I do like this. And then plus, we have to get the player camera manager. Basically, we're working on this. We have to get the camera manager, and it says it's gameplay statics, so let me just look up gameplay statics. I'll have to include something, I'm sure of it. Okay. Now I think I do gameplay statics, get camera manager, then I have to get camera location. I think that's all good. So that's basically that math. So I'm happy about that. So now we can go back. So that's rotation. So after we rotate the sun. Oh my god, there's so... Oh. There's a lot. Alright. So we're literally interpolating some stuff by alpha. So I think what we should do is just do all these things, right? So get sun color, get next sun color, current. Yeah, so get current, get next, and then lerp. So maybe we could do something like, and what is it doing it by? Time rate. And it's a linear color that it returns, no? Yeah. So maybe we could say something like F linear color. Sun lerp color equals Ukismet math library lerp linear color lerp. So the first one is current sun color get linear color value, and then the time is time rate. The next parameter is next sun color value. So get linear color value, time rate, and the last thing is alpha. That's alpha. Alright, so it doesn't like something. Alright, so we need to include that class, I think. So see what we have to include. So F linear color. Okay, so it's math color. Simple one. Let's see if that did the trick. Alright, so this can't be a pointer. I think we fixed this already with what we're doing with that include, but let's compile, let's see if we can get an exact error. If possible. Oh. God. Alright, so yes, total problem. Alright, so use of so U curve linear color. Okay, so I was wrong. Right? No. So I gotta include the curve. The thing I gotta do. What's the curve? Curve linear color. Surprised I don't have that, but okay. Okay, assuming that's valid. Okay, so it looks better. Okay. I think it needs an index, right? Okay, so this, then player index 0. Whoopsie. Should have known. All right. Okay. What's next? We gotta do the same thing for skylight color, fog color, and overall color. So skylight color. All right. Thanks for the follow. Much appreciated. Saints Resolve. Thanks so much. I appreciate it. Welcome. So we're doing skylight color. So then we need to do what? Current skylight color. And next skylight color. And there. And now we gotta do fog. Current fog color. Next fog color. All good. And then last but not least is overall color. Current overall color. Next overall color. Boom. Okay. So what we just wrote there is all of this and this. So now we're doing some multiplication. So we gotta set the directional light color. So directional light color. Just set light color. Do I have to include that class? Do I not have a light component class? I do have directional light component. Oh, because I'm setting the color thing, right? Yeah, whoops. So directional light, set light color. Now it's going to be sun lerp color times overall color. Okay. Now we gotta do the skylight. Skylight. That light color. Now it's gonna be skylight lerp color times overall, I believe. Then exponential height fog is next. Exponential height fog. And we're setting set fog in scattering color. And that's going to be fog lerp color times overall color. And the next thing for fog, exponential fog, that we're doing set directional and scattering color. This is going to be equal to, we gotta do some math here. We're going to say what? Float sun glow emissive equals cloud material. Get scalar parameter value. Okay, so we need to make two more variables. So this takes in what? Half hashed f. So sun glow material info. Float sun glow. Well, I guess I could do this, where it's like... that. Guess I can initialize it to 0. And I call this, and do sun glow, material info, sun glow emissive. Then, I don't know, false. Then, we do... I guess we could say sun glow emissive divided by 20 times, and then what is the sun color so sun lerp color times overall lerp color. That looks like it potentially checks out. I don't know. Oh, we hopefully did that correctly. Now we gotta set elements. So, oh. The pain here. Okay. All right, let's see if we can do this. If we can do this, then this will be the last thing we do today. So it's a sun billboard. So we got basically at the end of the day, we got to do sun billboard set elements. So it basically takes a T array of F material sprite element. F material sprite element. Sun elements, we'll call it. And we can just say sun elements. But now we gotta make this array. We gotta like tell it what's up. And I do like sun elements dot add. Like, what are the constructors I can do? I guess I could do like this, where it's like F material sprite element, new sun element. The new sun element. And then here I can break down each thing. So new sun element dot material equal. All right, so now we gotta make some new variables, I think. So moon material, sun material. Do I have either of those? Let's see if we have it. Sun material? No. Okay, we're gonna make those. So it's gonna be a material interface. Okay. Let's do it. So U material interface. I guess I have to say like class. Moon material. I gotta do called sun material. Okay, so we have our materials. Do we have rise time? We're gonna need more. I don't think we have that very. So let's make new ones. They're gonna be floats. The float, rise time. Oof. Okay. So we just made these two, and we just made these two. So now we got to do. I think we could do one of those famous tertiary if statements. So something in that, this, A, B. So what's our condition? Condition is downtime less than or equal to time and rise time is greater than or equal to time. So if true, sun material, if false, moon material. So I think surprised we got. Wait, I don't know if it's gonna compile. Let's try to compile. Let's see what happens. I ain't afraid of no ghosts. Surprised that worked. Okay. Cool. Stop worrying about that. Now we don't have to set anything. We have to. So distance to opacity curve is set to nothing right now, but let's do that. So dot distance to opacity curve equals null. Sun size. Yeah, new sun element. Dot size. Screen space equals true. New sun element. Dot base size x equals. Now we gotta do some more. So let's say float. I don't know. Billboard size equals. Now it's the same exact condition. Now, if true, sun size. Alright, so I don't think I had these variables for sun size and moon size, so we're going to go back. They're floats. Sun size by default is what? 0.5? We also had initial values for downtime. So downtime is 18. Make sure we do that. Don't forget. Rise time, 6. Okay, so now sun size, and then we need to do moon size. It's 0.15. Okay, we can go back. So now if true, sun size and moon size. Now, oh, am I forgetting? No, okay. Now we need more variables. Unless it's a little. So yeah, it's also in the sun category. So more floats. Base size X. And that's 1. Now base size Y, also 1. Okay. So base size X is going to be equal to billboard size times billboard. No, base size X. The new sun element dot base size Y equals billboard size times base size Y. There. And the last element is also going to be null. So dot distance to size curve. Null. Okay. So I believe we just believe we just did this. All this one. So now we just got to do one last thing. So we gotta do another scalar parameter thing with the collection. So I'm gonna copy this because it's the same exact thing. Except now it's set scalar parameter value. And then it's this NPC sky parameter name is going to be darkness. And then the float value, all right, so we need a new darkness parameter. So it's a curved float. We can copy one of these. Call it darkness param. Then we could take darkness param. Call get float value, pass in time rate. That should be it. So that's the end of set sun param. And I guess let's just fucking wrap up this fucking constructor. Yeah, because this is the last thing we need for the constructor. That's actually pretty good. We got a lot of code. Really don't know what I'm doing. That's the fun part. So, the last things that we need to do. Sunrise offset. I think we have that. And that's a float curve. Let's double check. Sunrise offset. Yes, we do. So we're literally... So do we have rise time and downtime as well? Yes. All right, so we have all the variables. So we're doing all that under set sun param. Now we gotta do, last but not least, So we gotta say rise time equals sunrise offset get float value, and these hard coding 0.25. Gotta do 0.25 minus that times 24 plus 6. So that's rise time. Downtime equals. So it's gonna be very similar, except it's times 3. It looks like. So instead of 2.5, it's 0.75. In both cases, 24 is consistent. Then 18 is the last. And boom. Oh, I guess I don't need that. Boom. That's this. These last two things. So I think that's it. Let's compile. See if we have any problems. Looks like we're in the clear. Boom. All right. We can stop trying to do that. Now we are done with the constructor. So just to recap, here's the construction script. We did this, we created this initialized setting thing, we created this, we did this, and all that, and we did this, did all that, did this, all that. And we did set sun param today. And then we finished off with this. So we're done with the constructing script. So now, it might be easy to do this tick debug. So we'll do that next time, and we'll do begin play. Yeah, so we're gonna have to. First, we'll have to create our time courses. So this is time. This is the sun. This is wind direction. What do we do with current direction? Okay, it's wind offset thing. All right. So we're done with the constructor script. So happy about that. Next time, we will do debug because it's easy. And then we'll have to do our time courses. So I'll have to remind myself how to do timelines. We did it for our pickups. I think we created this already. Yeah. So I think we have the means to do these time courses, so we're gonna be good for now. And that's where we're gonna end tonight. It was a short stream because I'm kind of exhausted. Thanks for everybody who stopped by. Thank you for the follow, Saints Resolve. Hopefully we'll see you next time. Everybody else, see you soon. Thanks a lot. Have a good night.